Okay, in this video, we want to find the general solution, and to do so, we need to get eigenvalues and eigenvectors. So we first need to define A. So we can say A is defined as, we will do a 2 by 2 matrix. So we hit this icon, choose 2 by 2, and just set it. So 3, 6, -1, and -2. So now it's defined, and since we're getting eigenvalues, we say A minus R, which is just making this minus R and minus R. And next we want to get the determinant. So menu, matrix and vector, 3 for determinant. Write A and S, answer. So now we have the determinant, but we want to get the roots. So we hit menu, algebra, we go to polynomials tools, and we go to 3, complex roots of polynomial, and we write answer, but it is important to write comma R. And so our two roots are 0 and 1, and so these two are our eigenvalues. And so the next thing is we're going to plug in each value. Each eigenvalue we'll plug in. And so we will hit control equal, we will define it, we'll set it, and we will say that R is equal to 0. It's not going to change because 0 is not going to do anything. And so next we will get the row reduced echelon form of this. So RREF, parentheses answer, and this is what we get. And so by this we know that V1 plus 2 times V2 is equal to 0. And so V1 is equal to minus 2 times V2. And so we can get our eigenvector. And so if we say V2 is 1, that means V1 would be -2. Because if we say V1 is -2, we divide by -2, that means V2 is 1. Hence V, the eigenvector, is this, associated with the eigenvalue of R is equal to 0. And next we need to get the other eigenvector. So the other one would be where R is equal to 1. And so we replace 0 with 1, and we do the exact same thing. So we do the row reduced echelon form, and we write answer, hit enter. This is what we get. Therefore V1 plus 3 times V2 is equal to 0. Or we could say V1 is equal to minus 3 times V2. And that means our eigenvector would be, if we plug in 1 for V2, then V1 would be -3. And so this is our eigenvector. And so we'll make the same statement. We will say that hence V, the eigenvector of this, is associated with the eigenvalue of R is equal to 1. And so we're almost there. And now based off of these two eigenvectors, we can make a general solution for x, and that will be this. And so we will say C1e raised to 0t. We get 0 because this eigenvalue is 0, and the eigenvector associated is -2, 1, plus C2e raised to t because 1 times t is t, and the eigenvector associated was -3 times 1. We can simplify it a little bit. We know that e raised to 0 is simply 1. And so our general solution will be this, because we know that e raised to 0 is 1. So we could say C1 eigenvector of -2, 1 plus C2 e raised to t, and the eigenvector was -3, 1. And so this is a general solution. And if you missed a step, I'll expand it. This is one part, so you can pause the video here, and the second part is this. And that's all we need to do for this problem. The general solution reminder was this, and that's it.